Okay, the last type of equation that we're going to cover today is the square root equations. So we want to explore what this graph looks like when the x has a square root and the y does not. These equations are called radical equations. So if the x has a square root and the y does not, then the graph, the square root of x plus 2, will look something like this. It's kind of like the U shape on its side, except the other half of it is like cut off, okay? So don't draw that part. It's like gone, okay? But you see how it's kind of U-y shaped? If you fill in the extra bits, it's kind of like that U shape, but we only have one branch of it, okay? Another example where the x has a square root and the y does not, like y equals the square root of x plus 2, is going to look like this. Okay, so the graphs can be shifted, moved around, but it's going to kind of be like that U shape, laying down on its side, but with one of its arms cut off. So let's try some of these. So normally what I do is I plug in -2, -1, 0, 1, and 2. And if you might want to just hold up on writing those, because I'm going to be erasing it in just a minute. When I plug in the square root of -2, I'm sorry, when I have the square root of -2, we have a problem. Why do we have a problem? Well, you're not allowed to take the square root of a negative. We already know that. Not only can we not take a square root of negative, so we shouldn't pick these values, we are only going to pick values that are positive or 0 that are perfect squares when they're under the radical. So I am going to start with 0 here. So I have y is equal to the square root of 0 plus 3. Do you know what the square root of 0 is? Yeah, that's 0. So 0 plus 3 is 3. So whenever you're working with square root equations, you just don't want to pick any random points like -2 through +2. What we're going to do is we're going to be a little bit particular here. So the next one, let's plug in 1. Y is equal to the square root of 1 plus 3. Do I know what the square root of 1 is? Sure I do. The square root of 1 is 1. And 1 plus 3 is 4. Alright, you might want to hold up on erasing on doing this because I'm going to erase it in just a minute. When I do 2, y is equal to the square root of 2 plus 3. Okay, now the square root of 2 is defined, but if I don't have a calculator, I don't know how to figure that out. It's like 1.4 something. I don't really know. So I'm the author of this problem. Do I really have to pick x's too? Well, I don't. I can erase this and not pick 2. I can pick whatever values I want. So I want you to think of the next perfect square after 1, that when you plug it in, you get a perfect square. You get a whole value. And the next perfect square I can think of is 4. Because the square root of 4 is 2. So I'm only picking values that I know in my head will work. So that gets me 5. What do you think the next value would be here? The next perfect square I know of is 9. So when I plug this in, the square root of 9 is 3, and 3 plus 3 is 6. So I'm being a little bit particular and picking values that I know will help me. Now clearly 9 is off my 7 by 7 graph, so I'm not actually going to be graphing this one, but I just wanted to get you to get the feel of where the values are coming from. So when I plot 0, 3, that's left and right 0 and up 3, 1, 4, 1, 2, 3, 4, 5, and the next one would be like out here 9, 6 off my picture. And there is my square root equation. It looks like a parabola laying on its side with its arm cut off. Alright, next one. This one's also a bit tricky because I want values that when I plug into x, I am getting a perfect square. Now because the 1 is underneath the radical this time, picking perfect squares aren't necessarily going to work all that well. Let's start off with 0, because I just kind of don't know where exactly to start. So let's start with 0. And when I have 0 plus 1, that gets me the square root of 1, which is 1. So I am considering what happens if you plugged in negative 1. The square root of negative 1 plus 1, that gets me the square root of 0. Hey, look at that. That works. Oops, and that's 0. What if I plugged in negative 2? The square root of negative 2 plus 1 is the square root of negative... nope. That is not going to work. So it looks like negative 1 comma 0 is my first working value. Okay, so let's try the next one, 1. 1 plus 1 is the square root of 2, which, I don't know, that's like 1.4. It's an okay point. It's a good solution. It's just not something that I'm going to be able to graph very well, okay? So I might probably not graph that one. So I guess what I'm looking for is what value here plus 1 adds to a perfect square. Well, the next perfect square I know of is root 4. So what value here can add to 1 to get the square root of 4? And I think the answer there is 3. So if I plug in 3, the square root of 3 plus 1 is 4, and the square root of 4 is 2. All right, let's try one more. What value plus 1 is the next perfect square? Well, the next perfect square after 4 is the square root of 9, right? So what value plus 1 is 9? And that is 8. So if I plug in 8, that gets me the square root of 8 plus 1 is the square root of 9, and the square root of 9 is 3. So I'm not going to plot the one that I don't know. I don't know what the square root of 2 is in my head. But I can plot negative 1 comma 0, 0 comma 1, 3 comma 2, and 8, which is right off my picture, comma 3. Again, that's a beautiful square root picture. The last topic for today is the interval notation. Now the interval notation may not seem like it fits with this lesson, but I wanted to make sure we saw it early on because we're going to need it for a lot of lessons this semester, so I wanted you to be able to see it early on. So I put it with this lesson. So interval notation is used to describe an interval of numbers, so lots of numbers that are really close together in a concise way. So to describe a continuous interval of numbers, we use the endpoints to describe the beginning and ending of the interval. If the endpoint is included in the interval, then you will see a closed circle on the graph, and we will use a bracket for the interval notation. If the endpoint is not included in the interval, then you will see an open circle on the graph, and we will use a parentheses for the interval notation. Now, if the graph has an arrow, implying that it keeps going on forever in one direction, then the interval continues to positive or negative infinity. Now, since you can never actually include infinity, so we'll say since you can never include infinity, then we will always use parentheses with the infinity symbol, and this is the infinity symbol there. So on this first problem, I want all of the values from negative 2, yes values, all the way up until 6. That line in between means all of the values between. So my endpoints would be negative 2 and 6. So I put the negative 2 first and the 6 last. I always use low comma high. The lowest one is on the left, the highest one is on the right. So my intervals last from negative 2 all the way up until 6. Can I include this? Yes, because it's a closed. So closed get bracket. How about the 6? Does the 6 have a closed? It certainly does. On the next one, my endpoints are negative 4 and positive 2. I need all of the values in between it, so I'm going to use interval notation. All the values between negative 4 and 2. I can include 4, so it's use a bracket. I cannot include 2 because it has an open circle. So the open circle tells me that I should have a parentheses there. On the next one, I want all the values from -2 to 6, so my endpoints are -2 and 6. My -2 has an open circle, so I'm going to use a parentheses on both of these. Now the next one is very similar. It's all the values from -2 to 6, but in this case, the first one has an open circle, so that's going to be a parentheses on the 2, and the 6 has a closed, which means it will have a bracket. You are allowed to have one of each. All right, so now we have all of the values from +6 all the way going to the left forever. Now, as I said, we're going low, comma, high. So we're going, in this case, left, as far left you can go, comma, how far right you can go. So 6 is my endpoint, but it's my endpoint on the upper side, so it's going to be on the right-hand side because that's the highest value. The lowest value, this arrow, says I can go all the way down to infinity, but we call that negative infinity when it's to the left. Positive infinity would be to the right. So can I include the 6? I certainly can, so I use a bracket. Can I include infinity? Well, no, there's no way that you can ever include infinity in your endpoint, so you always use parentheses for infinities. Alright, next I have all the values from 2 to infinity. So 2 is as low as I can go, so it goes on the left. To how high can I go? Well, this arrow says forever, so I'm going to go positive forever. So that's going to be up infinity. I can't ever include infinity, so I always put a parentheses on that. Can I include the 2 this time? Well, not this time because it's an open circle, so I need to put a parentheses. Alright, the next one has an arrow going to the left, so how low can I go? Negative infinity, comma, how high can I go? Well, the highest I can go is 6 this time. I can never include infinity, so I always put a parentheses there. And in this case, I can't include 6 because it has an open circle. Alright, this next one starts from -8 and it goes up to infinity. So I start from -8 is my low. My arrow points up forever, so that's a positive infinity. On the 8 has a closed circle, so I'm going to put a bracket on the -8. And the infinity, I can never include infinity, so I always use parentheses on infinities or negative infinities. Alright, here's a tricky one. So this arrow goes all the way left forever and all the way right forever. Another way we sometimes write this is all real numbers. But in interval notation, which I think is a more concise way of writing this, what we're going to do is we're going to say how far left can you go? Well, negative infinity because the arrow says to forever to the left, and the other arrow says forever to the right, which means positive infinity. So I use parentheses on both because you can never use brackets on infinities. So this is another way of writing all real numbers in interval notation. We'll be using that several times. And that completes this lesson.